So today we're working with section 5.1, which is rate of change and slope. Hopefully we've heard some things about rate of change and slope in previous classes, but here we go with this. So hope by the end of the section you can say I can find rate of change and slope from tables and graphs. So to get us going with this, we're going to look at this first problem here, and it says the table shows horizontal and vertical distances from the base of a mountain at several poles along the path of the ski lift. The poles are connected by a cable, between which two poles is the cable's path the steepest. So if we were to plot these points on this graph, so this is going by tens, this would be 20, 40, 60, 80, 100. Same thing here, this would be 20, 40, 60, 80, 100. So at 20 horizontal distance, we're at a vertical distance of 30. At 40, we're at a vertical distance of 35. This is pole A, pole B. Pole C at 60 is at 60 high. And pole D is at 170. So visually it is easy to see where between which two poles it is the steepest. It's easy to tell that between pole B and C that we have the steepest section of cable. So now the question is, how can I tell it more mathematically? And that's kind of what we're going to start looking at today. And one of the ways that we're going to start talking about it is by comparing how much it goes up to how much it moves over. So that is known as our slope. So let's first take a look at this next slide though. So rate of change is this. It shows a relationship between two changing quantities. When one quantity depends on the other, the following is true. The change in the rate of change is this, the change in the dependent variable divided by the change in the independent variable. And slope, very similar, is when we're looking at a graph, vertical change compared to the horizontal change, often referred to as rise to run or rise over run. Okay, so if I wanted a rate of change here, it says the rate of change is constant. Find the rate of change and explain what it represents. Well, we're going to kind of work backwards. So if I found out what it represents, we'd be talking about here fences per hour. Okay, that's what our rate of change is going to be. So to do that, we can look at how much things are changing. So we can see here that this changes 1 where the hours change 3. This changes 1 when the hour changes 3. So what does that mean? It means that we could do 1 fence for every 3 hours. Okay, 1 fence for every 3 hours. That's what our rate of change is telling us. So this one, same idea. We're going to be looking at miles per hour. How many miles in 1 hour? So here we went 2 and 70, 4 and 140, and so on. So we know that we went up 70. Here we went up 2. Here we went up 70. Here we went up 2. So 70 miles in 2 hours translates to 35 miles per hour. Okay, that would be our rate of change. This would be 1 fence for every 3 hours. That would be our rate of change for that one. Okay. Now, if we want to look at slope, slope is simply a comparison of rise to run. So how much does it go up to how much does it go over? So if I look at 2 points here, if I just take a look at these 2 points, okay, how much does it rise? Well, it goes up 1 and it goes over 1. So the rise is 1, the run is 1. So the rise to run 1 to 1, which is a slope of 1. Okay, if I looked here, always looking from left to right, rise over run. Okay, so the rise, left to right. I know that I go down 2 units. So my rise is a -2. Down 2, so it's a -2. My run, how much do I go over? Well, from this point over, I go over 1. So my slope is -2 over 1, which simplifies to a -2. Okay, this next one. Again, rise over run. Rise over run. So if I looked at my rise on this one, I'm going down 1. So that's a -1 for a rise. I go over 3, so my run is 3. So my rise over my run is a -1/3. Or my slope is a -1/3. Okay, so I'm going to let you try and figure out the slope here. So if you want to pause the video, try and figure it out. So according to me, this would be a down 2. So my rise is a -2. My run in this one, I go over 3. So I go down 2. I go over 3. So my slope would be a -2/3. Okay, so now if I plotted these 2 points, 0, 4, and 7, or 5, 7. 0, 4, and 5, 7. Okay, and I find the slope. So I've got a line that goes through these 2 points. If I found my slope, which is rise over run. So here I can see that I go up 3. So my rise is a 3. Okay. My run, I go over how many? 1, 2, 3, 4, 5. I go over 5, so my run is 5. So now, my slope would be 3/5. The question I have is, how could I find the slope from the ordered pairs without graphing? So if I were to look at these 2 ordered pairs, I got a 0, 4, and I've got a 5, 7. So how can I get a 3 from these ordered pairs? How can I get a 5 from these ordered pairs? Hopefully, we can see that these 2 numbers, if I take a look from a 4 to a 7, that gives us a 3. And from a 0 to a 5, that gives us 5. So one way to think about slope is this. Slope is the change in the y's compared to the change in the x's. So if I just look at my, from a 4 to a 7, I go up 3. From a 0 to a 5, I go up 5. So my slope would be 3/5. Okay, if I gave you another one, if I said my ordered pair is 1, 5, and a -2, 7. So if I look at my y's change 2. I go up 2. My x's, I go from a 1 to a -2, so that's down 3. So my slope would be a 2 over a -3. Okay, if you want a more formal definition of slope, we can look at the formula at the bottom here. If I could. Okay, so our slope says this. Our formula right here. Rise over run, y2 minus y1 over x2 minus x1. So we subtract our x's, we subtract our y's. So let's take a look at that formula. So make sure you get that in your notes. You may have to pause it and copy that down. But then let's look how that works here. So number 7. We'll just do a couple of these. So I got -4, 5, and a 1, 1. So first way we talked about is how much does it change. So from a 5 to a 1, I'd say I go down 4. From a -4 to a 1, I say I go up 5. So my slope would be a -4/5. Now, the other way that you can look at it is this formula, y2 minus y1 over x2 minus x1, which means your second y, which is a 1, minus the first y, which is 5, over the second x, which is 1, minus the first x, which is a -4. And if you do the math there, 1 minus 5 is a -4. A 1 minus a -4 is a +5. So either way, we do come up with a -4/5. Okay, so if I looked at number 10 now, if I looked at these, so from a 3 to a -4, I know I go down 7. So my rise would be a -7. From a 5 to a -2, I know I go down 7. So it's a -7 over -7, which is a +1 for a slope. If we looked at using the formula, it would be a -4 minus a 3 over a -2 minus 5, which is again gives me -7 over -7, which is still just a 1. Okay. Find the slope, and if we cannot see the line, we're looking at this right here. So now, two little details we gotta worry about. If we've got a vertical line, the rise compared to the run, it keeps rising and it doesn't move over. So we got some number, we could say an 8 over a 0. Well, anytime you divide by a 0, we know that that is undefined. So any vertical line, we say the slope is undefined. Okay, now over here on this one, we got a horizontal line. So this time, it doesn't move up or down, but it keeps on running. So we could say that it's a 5. 0 divided by anything is a 0. So a horizontal line, our slope is 0. Okay. So without graphing, tell whether the slope of the line models the linear relationship is positive, negative, 0, or undefined, then find the slope. So 1 gene costs $22.50, 3 genes cost $67.50. So could we find the rate of change? Is it a positive? Yes, it's positive because the prices are increasing. And how would I find the rate of change or the slope? Well, 67.5 minus 22.50. We know the price went up $45. And 3 minus 1, we know our jeans went up $2. So that's $22.50 per pair. And we could have told that right from this first part as well. Okay, the second one, we got $28.50 for 3 hours or $237.50 for 25 hours. So it is another positive increase. And then we can look at, okay, how much does the pay increase? So you'd have $237.50 minus $28.50, which is $209. It goes up. And we went 25 minus 3 hours is 22. So $209 for 22 hours. That's $9.50 per hour. Okay. Last one. Just want to work on independent, dependent here. We'll worry about, you can find the rate of change as well, but the cost of 3 gallons is $8.85, 5 gallons is $14.75. So independent, dependent, independent, dependent. So what depends on what? I would say the dependent is the cost. The independent is the gallons. Number of gallons you buy will determine the cost. Okay, next you could find the rate of change, and I'll let you figure that out. Okay, we got 10 envelopes in a minute or 100 envelopes in 10 minutes. So I think independent, dependent. What's dependent? I'd say the number of envelopes depends on time. So you could do your division to find your rate of changes there as well. So that is all I have for you today. Hopefully this makes sense. If not, come with your questions. Okay, and that, my friends, is a wrap. One shout out to, let's see, shout out to my second period.